sorry to disturb you. You have received a message from Cybertron.
Welcome to Defense Cassette. I'm Sonal, your defense anchor. Hope you will enjoy this video. Research and Development Organization's DRDO Aeronautical Development Establishment (ADI) is gearing up to unleash a formidable array of made-in-India weapon systems on its latest creation, the Armed Archering Medium-Altitude Long-Endurance Male Unmanned Aerial Vehicle (UAV). The Archering, set to roll out later this year, is lined up to be equipped with a diverse range of weapon systems to make it a potent combat UAV, capable of tackling a variety of missions. The Armed Archering is designed to carry a payload of up to 300 kilograms with its 4 hard points, providing the flexibility to integrate different combinations of weapon systems. One of the key weapons in the arsenal of the Archering is the third-generation Fire and Forget UAV-launched Precision-Guided Munition (ULPGM) anti-tank guided missile. With a range of 4 kilometers, this missile is capable of taking out soft-skin targets, vehicles, bunkers, tanks, windows, and fast-moving targets, making it a versatile and lethal tool on the battlefield. DRDO has also planned 3 more variants of this missile, with an extended range of over 6 kilometers, further enhancing its potency. Another formidable system planned for the Archering is the DRDO Smart Anti-Airfield Weapon, which weighs only 125 kilograms but boasts an impressive range of 100 kilometers. This weapon is specifically designed to engage ground targets with high precision, ensuring that enemy airfields and critical infrastructure can be neutralized effectively. In addition to precision-guided munitions, the Archering will also be equipped with laser-guided rockets and bombs, further enhancing its capabilities in environments with limited air defense systems. These precision weapons enable the UAV to accurately engage targets and minimize collateral damage. To expand its reach and versatility, the Archering will also carry UAV-launched loitering munitions. These gliding munitions can cover distances of up to 100 kilometers. The organization plans to collaborate with private sector companies to develop a mini-cruise missile that can be launched from an armed UAV. This mini-cruise missile will be designed to take on highly defended targets from long standoff ranges, further enhancing the Archering's strike capabilities. Safran Aeronautics Limited (HAL) prepares to conduct trials of the Hammer missiles. These advanced missiles were originally ordered from France to equip the Rafale fighter jets, but they have now been selected for integration into India's indigenously developed LCA Tejas fighter jets as well. The Hammer missiles have gained prominence in the Indian defense arsenal after fresh orders were placed in 2021 for their procurement, extending beyond the initial purchase of the Rafale jets. HAL, one of India's premier aerospace and defense organizations, has taken on the task of incorporating these powerful munitions into the LCA Tejas fighter aircraft. The development process has reached a significant milestone, with HAL completing shroud separation on the Hammer missile. This critical step was achieved using computational fluid dynamics, a cutting-edge technology that simulates fluid flow and other dynamic processes. The successful shroud separation paves the way for the upcoming trials of the Hammer missiles, which will assess their performance and integration with the LCA Tejas fighter jets. The integration of Hammer missiles into the LCA Tejas fighter jets will further bolster India's defense capabilities, providing the Indian Air Force with a versatile and effective weapon system. The Defense Research and Development Organization (DRDO) of India has embarked on an ambitious journey to develop a cutting-edge modular small satellite launch vehicle, codenamed Veda, specifically designed for rapid integration into the launcher. This project, recently approved in principle by the Ministry of Defense (MOD), is a significant stride in India's space endeavors, aiming to enhance its capabilities in deploying defense satellites for a range of critical applications, including surveillance, communication, and navigation. The Veda small satellite launch vehicle is envisioned as a 3-stage, solid propellant rocket capable of carrying payloads weighing between 150 to 650 kilograms to low Earth orbit (LEO) from mobile launch platforms. This state-of-the-art SLV will be a game-changer in India's defense landscape, providing the armed forces with an independent and flexible means of deploying vital satellite assets to bolster their operational readiness and strategic intelligence. One of the key factors contributing to the accelerated development of the Veda SLV is the utilization of existing technology and expertise from the K-4 submarine-launched ballistic missile (SLBM) for its first stage. Leveraging the K4SLBM technology will not only expedite the development process but also lead to cost savings, ensuring that the SLV is reliable, efficient, and tailored to meet the specific requirements of the Indian Armed Forces. The first stage of the Veda SLV will be powered by a solid propellant rocket motor based on the K4SLBM, providing the initial thrust needed to lift the vehicle from the launch pad. The subsequent stages, the second and third, will also be equipped with existing DRDO solid propellant rocket motors, ensuring consistent and reliable propulsion throughout the launch sequence. A notable feature of the Veda SLV is its road-mobile nature, allowing for greater flexibility in launch locations. This mobility grants the Indian Armed Forces the advantage of choosing optimal launch sites based on mission requirements, enhancing operational agility and strategic response capabilities. With a payload capacity of up to 2,000 kilograms and a maximum altitude of 200 kilometers, the Veda SLV promises to be a versatile and powerful asset in India's defense satellite arsenal. It will enable the deployment of a wide array of defense satellites into lower orbits, facilitating real-time surveillance, seamless communication, and precise navigation for military operations. In the rapidly evolving landscape of modern warfare, the ability to detect and counter stealth technology has become a critical aspect of national defense. India's Defense Research and Development Organization (DRDO) is at the forefront of this endeavor, spearheading the development of various anti-stealth radars that promise to revolutionize the way stealth threats are detected and neutralized. Stealth technology, designed to render aircraft and other military assets nearly invisible to traditional radar systems, has posed a formidable challenge to conventional defense mechanisms. However, DRDO's relentless pursuit of innovation has led to the conceptualization and development of a range of cutting-edge anti-stealth radars, each equipped to tackle different dimensions of stealth warfare. Low-frequency radars. These radars operate in the low-frequency spectrum and offer unique advantages in detecting stealth aircraft, which tend to have reduced radar cross-sections at higher frequencies. Low-frequency radars can penetrate through various environmental and atmospheric challenges, making them exceptionally effective in detecting stealthy threats even in adverse conditions. Multi-static radar. This innovative radar system employs multiple radar stations that work collaboratively to detect stealthy targets. By leveraging the concept of multilateration, where signals from different radar stations are analyzed to determine the location of a target. Multi-static radars enhance detection capabilities and significantly reduce the chances of evading detection through stealth technology. Over-the-horizon radar. Over-the-horizon (OTH) radars possess the unique ability to detect targets over long distances beyond the curvature of the Earth. These radars can scan vast areas and provide crucial early warning capabilities, making them invaluable in countering stealth threats that attempt to exploit surprise and speed. Passive coherent location radar. Unlike traditional radars that emit signals and receive their reflections, passive coherent location (PCL) radar relies on ambient signals from sources such as commercial broadcasts, mobile phone towers, or satellite signals. The PCL radar's ability to detect and track stealth aircraft without emitting any signals of its own makes it an extremely coveted and effective tool in detecting stealthy incursions. Significant development for India's defense sector. The government informed Rajya Sabha that the total value of offset contracts linked to defense deals currently stands at a whopping $13.21 billion. Out of this amount, foreign military contractors have submitted claims amounting to $6.85 billion. This reaffirms India's commitment to boosting indigenous capabilities and achieving self-reliance in the defense sector. India's offset policy mandates that in all capital purchases above 300 crore, the foreign vendor must invest at least 30% of the purchase value in the country to enhance domestic capabilities. Notably, in the case of the 59,000 crore Rafale deal for 36 fighter planes, this obligation was set at an even higher percentage, at 50%. The fact that no offset obligation has lapsed in the last 5 years showcases the seriousness with which the government is ensuring compliance with these agreements. The quantum of offset due currently stands at $0.12 billion, indicating that substantial investments are being made to fulfill these obligations. Minister of State for Defense, A.J. Bhatt, clarified that penal action is taken against vendors who default on their offset commitments in accordance with the relevant provisions of the Defense Offset Guidelines. The recent 21,935 crore deal signed with Airbus Defence and Space to equip the Indian Air Force with 56 C-295 aircraft also includes an offset element of 30%. Tata Advanced Systems Limited and Airbus are jointly executing this program, with 16 aircraft being delivered from Spain in a flyaway condition, and the remaining 40 to be built in India. The offset policy's primary aim is to develop India's defense sector and achieve self-reliance, reducing dependence on imports. By encouraging foreign vendors to invest a significant portion of their contract value in India, the country can bolster its indigenous manufacturing capabilities and become less reliant on external sources.